Hey, welcome to Secret Lab Reports. Today, we'll be looking into black holes.
Oh god, I look too deep! To the secret lab!
Black holes are gravity wells, created when objects get condensed into an extremely small area. Before the term black hole was coined, French mathematician Laplace theorized of objects with escape speeds or velocity that could exceed light. The escape speed or velocity is an object's necessary speed requirement at a minimum to escape the gravitational influence of a massive body. All massive objects curve space-time around them, allowing other objects to attract. Earth's escape velocity, for instance, is 11.2 kilometers per second, which is Mach 33. If an object has the same escape speed as light, we call it a black hole or singularity. Another famous mathematician, Schwarzschild, gave us a calculation to help us determine the gravitational radius at which light could not escape. The Schwarzschild radius, now called the event horizon, gives a black hole its iconic black appearance. Anything that passes through that event horizon will never interact with the visible universe again. Black holes come in all sorts of sizes. Some may even be smaller than subatomic particles. Large black holes occur when stars collapse due to a lack of outward pressure. To get a better understanding of how this works, we need to take a look at the natural life cycle of large stars and binary star pairs. All stars have fusion in their core. That fusion creates the heat and energy for pressure necessary to stop the star from collapsing on its own gravity. Not all stars end up as black holes. If a star's initial mass is insufficient when it dies, it will burn through its core and go through a different process. When a smaller star runs out of fuel, it usually expands and then naturally decays into a nova, leaving a planetary nebula. This will inevitably happen to our star. It will burst into a planetary nebula and leave behind a small core where the sun once was, a white dwarf. As dense as white dwarf matter is, the degenerate electron matter still prevents it from collapsing any further. That type of matter is too dense, and its own electrical forces prevent the gravitational forces from overwhelming it. If a white dwarf is given the opportunity to gain more mass from a binary pair, or a larger star collapses, it can collapse even further into the neutron star. Neutron stars are the last phase between a totally collapsed star and a black hole, if you include the exception of strange matter stars, which are theoretical at the moment. Neutron matter is a more dense version of degenerate electron matter, consisting entirely of neutrons. Neutron matter is so dense that a teaspoon of the stuff would weigh as much as the entire planet Earth. Our sun's just a little bit too small to be a neutron star, 1.4 times its matter and it would qualify. Neutron stars can get about as big as 10 times our solar mass before they eventually break down into the black hole. In recent news, the Laser Interferometry Gravitational Wave Observatory, or LIGO for short, has gotten some mildly conclusive results of mergers for neutron stars through their gravitational wave studies. If a star has more than 10 solar masses to start with its initial mass, it will inevitably break down into a black hole at the end of its life, resulting in a massive explosion called a supernova. When a white dwarf gains enough mass and collapses into a black hole from its binary pair, we call that a Type 1a supernova, and it's used to help recognize distances in space. They call these types of supernovae standard candles. As black holes age, they can gain mass from their surroundings. As a black hole feeds, it gains more and more mass and eventually more gravitational influence. Feeding black holes, called quasars, have an accretion disk of gas around them as objects brought near them are broken down and torn apart. Gas near the black hole, falling in, has the option of either accelerating and running into other gas, or being brought into the event horizon never to interact again. The gas that does flies off in two spirals made of gamma radiation from the intense collision. If the point at which the collision occurs is pointed towards us, we get to see that gamma ray directly. We call those types of quasars blazars, because I could have named that just as well. The biggest types of black holes are called supermassive black holes. They have solar masses that are hundreds, thousands to billions of times that of our star. Every galaxy of significant size has a supermassive black hole at its center, and without it, it may not even have been able to form. Large black holes that form from star collapse are probably the most familiar kind, but are not the only type of black hole. The smallest a black hole could be is 22 micrograms, as long as it consisted in the same space as a Planck length, the smallest theoretical length. Scientists have theorized of primordial black holes that have been in existence since the start of time, smaller than subatomic particles and thus undetectable. One such object, called a Kugelblitz, could theoretically be created by shooting an intense amount of light at the same location, creating its own event horizon and trapping it there. Scientists have even theorized that a Kugelblitz would make a great type of battery for any starcraft, allowing it to travel with almost limitless energy for thousands of years. Of course, the Kugelblitz would have less energy in it than what was used to create it, but it's still more portable than having to lug a star with you. What are your thoughts on black holes? Let us know in the comments below. Don't forget to like, share, and subscribe, and check out MilwaukeeAtheist.com live now.